experiment 2. Right? Write down. Write down. Determination of angle of minimum deviation. Determination of angle of minimum deviation of a prism. Determination of angle of minimum deviation of a prism by observing the variation of deviation of a ray through a prism. Right, listen. The respective theory is this. Don't write, just look at the board. Respective theory is this. We know refraction through a prism. So this is an equilateral prism. It is not a must to be an equilateral one, right? But we are using the equilateral one for the ease of calculations, right? Say a light ray, incident light ray, falls onto this surface of the prism A, B, C, like this, right? So basically, this will follow this kind of a path, right? Something like this. This ray is called what? Right? Theory is incident ray, right? This is called the incident ray. Incident ray. This one, refracted ray. Refracted ray. This one, emergent ray, right? Emergent ray. Emergent ray, right? Angle between two refractive surfaces is called prism angle, right? This is the first refractive surface. This is the second refractive surface. Angle between two refractive surfaces is called prism angle, capital A, right? And all angles are measured with the normal. So this is I1, say R1, R2, I2. Make a standard day then make I1 because it satisfies ordinary property of light. Light ray consider angles set right. Then mark angle of deviation. What is deviation? Deviation. Deviation. What is deviation? Online? What is deviation? All clear, all good. Right, good. What is deviation? Clear definition among angle between final and original directions of light ray. Right, angle between original and final directions of light ray. Doesn't matter how many refractions are taking place in between. Right, refractions 10 tibba to first guy last guy. Okay, the angle of deviation. Right, then my original ray is here. See, original ray is here. Original ray is here. Final ray is here, emergent ray. Final ray then angle between these two, this is called capital D, angle of deviation. Right? Capital D, this is angle of deviation. If you are using different colors, you can use different colors, right? Angle of this is the original direction of light ray. Make extend this direction. This is the original direction of light ray. And this is the final direction of light ray. Angle between these two is the angle of deviation. Right? Angle of deviation. The reason to have a minimum deviation is when we increase angle of incidence, right? Angle of deviation first decreases and reaching a minimum value and then increases. Right? Api graph graph verify theory graph this is the respective experiment to verify this variation. DNI graph DNI variation variation verify experiment. So when we are discussing this in the theory, for the sake of doing questions and all the proofs, I gave you the graph. This is an experimental result that will be conducting in the class. Right? Make the experiment. Then make in the shape right? Make theory because This is something we are going to verify, right? Theory එකේ මේ ටික දැනගෙන හිටියා නම් හරි. Especially we are going to plot the graph between deviation and I know. So deviation එක තමයි අපි මේක මාක් කරගන්න ඕනේ. Right? Take this down. Okay. Write down. If angle of minimum deviation is d min, write down. If angle of minimum deviation, if angle of minimum deviation, if angle of minimum deviation is d min, if angle of minimum deviation is d min, n equals, अब मैं प्रूव करा. What's the equation? N equals dense prism in a rare medium. N equals sin a plus d min over 2 sin a plus d min over 2 over sin a over 2, right? Right? මේකෙන් n එකම හොයාගන්න පුළුවන්. අපි d min එක හොයාගත්තට පස්සේ. Mention it. Right, listen. Write down materials and apparatus. Materials and apparatus. Materials and apparatus. Right. Mention them one by one. First one. A white sheet. A white sheet. A white sheet. Second one. Drawing board. Drawing board or a drawing board. Then drawing pins. Drawing pins. Drawing pins. Next one. An equilateral prism. An equilateral prism. An equilateral prism. Next, 4 optical pins. 4 optical pins. 4 optical pins. 4 optical pins. Then a ruler. A ruler. A ruler. Last one, a protractor. A protractor. A protractor. Right. Listen, I'm going to explain the method. Method is experiment. Right? If the method is clear, which means you know what exactly is conducted, is done in the experiment. Modification still you can tackle it. Right? Then structured more than 80% you can write just by what is given here also. Right? If you can parrot what is given here, around 16 marks out of 20 you can write. 16 ලියන්න පුළුවන්. ඒතොර මේක කතා කරන්නේ 16 නෙමෙයි 20 වලටත් වඩා ඕන ලියන්න පුළුවන්. ඒ කියන්නේ මේක extensions කොච්චර කර ආවත් ඔයා concept එක දන්නවා නම් ඉතින් එහාට ඉතින් මේ experiment එක ලියන්න ප්‍රශ්නයක් නැහැ. That's the thing. experiments එක පාඩම් කරගන්නේ කොහොමද කරන්න ඕනේ. හැබැයි හැම එකේම concept එක understanding එක තියෙනවා කියලා කියන්නේ ඔයාව 20 out of 20 ම ගන්න ලියන්න පුළුවන්. Because when it comes to experiments, that is actually a 20% of marks out of 100. They can finally go 20% of marks you can take from home. අපි දන්නවනේ එන්නේ මොකද්ද කියලා ස්ට්‍රක්චර්ඩ් වල. අනිත් ඒවා එහෙම නැහැනේ. අපි අනිත් ඒවා එන්නේ මොකද්ද කියලා දන්නේ නැහැනේ. questions වල මේකේ අපි දන්නවනේ මොනවද එන්න තියෙන experiments කියලා. ඉතින් ඔය තියෙන 38 experiments වලින් හතරක් එන්නේ කියන්නේ කොහොමද දන්නවද? ඉතින් 30ක් පාඩම් කරගෙන ඒකෙන් හතරක් ලියන එකේ මහා ලොකු කේස් එකක් නැහැ. 30ක් කියන එක ලොකු එක නම්බරයක් විදිහට ලොකු උනාට ඒක හැමෝම පාඩම් කරනවා. එහෙම තමයි. ඉතින් ඒක දන්න එකක් නේ. අනිත් questions වගේ නෙමෙයි. අනිත් question එක full random question එකක් නේ that you are going to get at the exam. You are going to see it for the first time at the exam. Right? ඉතින් දැන් මේක එනවා නම් මේක එන්නේ මේකමනේ. structured එක කියලා. ඒක තමයි ඉතින් ඕක තියෙන්නේ. So when it comes to structured marks, that is something we can take from home. එහෙම තමයි. Right, method dem hemai. See, now we have a white sheet now. First, white sheet should be firmly fixed to the drawing board using drawing pins. Should be firmly fixed to the drawing board using drawing pins. Right? And somewhere in the middle of the white sheet, to have a good spread, we have to mark some angles. Right? Usually we are starting from 30. Right? 30 wage nam padang aragena for 7-8 points we have to have different angles. Usually we are increasing 5 by 5. Right? ඒ කියන්නේ මෙහෙම වැඩක්. Say this is 30. Right? මේ angle of incidence තමයි මම මේ mark කරන්නේ. Angle of incidence 30. Then angle of incidence product එකක් තියෙනවනේ. ඒකෙන් measure කරලා mark කරන්න ඕනද? Then 35. Then 40. 45. 45. 45. Right? තව තියෙනවා ඉතින් ඔක්කොම ටික අඳින්න ඕනේ නැහැ. මෙන්න මෙහෙම. So you have to mark like minimum 6, usually 7 to 8 අපි ඔක mark කරගන්නවා. Right? 30 වලින් නම් පටන් ගන්න 30, 35, 40, 45, 50, 55, 60 ඔය වගේ angles ටිකක් 5 by 5 right 10 by 10 කරන්නත් පුළුවන් right usually 5 by 5 කරනවා right then we have an equilateral prism right take the equilateral prism and keep one side of the prism as it is aligned to this main line right then the prism will be like this මෙන්න මෙහෙම දැන් prism එක තියෙන්නේ right now to mark the direction of the light ray which is coming from this angle we have 4 pins now we are fixing 2 pins here and here right 2 pins like this මෙහෙම pins දෙකක් mark කරගන්න මේ line එකේ දැන් තියෙන්නේ pins එක line එකේ තියෙනවා then they are collinear මේ දෙක කොහොමද line එකේ තියෙනවා අපි line එක අරගෙන ඉවරයිනේ pins දෙක ගහ ගන්නවා ගහගෙන compare it with this now refraction after the refraction through the prism emergent ray should be seen from the opposite surface no එහෙනම් දැන් මෙතන ඉන්න දැන් refraction එක වෙන්නේ යන්නේ this is going to rotate like this මෙන්න මේ surface එකෙන් බලුවා නම් එහෙනම් මට මේ refraction එක පේන්න ඕනේ හරිනේ මේකම compare කරලා බලන්න මෙතනින් එන ray එක මෙහෙම ඇවිල්ලා මෙන්න මේ පැත්තට එනවා හරිනේ මේ මෙන්න මේ diagram එක තමයි මෙහෙම වෙලා තියෙන්නේ තේරෙනවද then prism angle is going to be this ඔන්න prism angle එක තමයි around that prism angle this rotates එහෙනම් මේ surface එකෙන් මම බලුවා නම් හරිනේ let me label this as ABC now we can observe the image of these pins say P1 and P2 now we can observe the image of these pins through the AC surface right when we are taking our eye from C to A or A to C along the AC surface at some point you will start seeing the images of P1 and P2 right දැන් මේ light ray එකක් මේ පැත්තට එනවා කියලා කියන්නේ අපිට අරගේ image එක පේන්න ඕනේ ඉතින් මේ පැත්තේ image එක පේනවා මෙතනින් image එක පේනවා you are taking your eye from here to here or here to here තොර දැන් මේක තැනක පේන්න ගන්නවා you will see both pins දෙකම පේනවා දැන් අපි මෙහෙම eye එක මෙහෙම කරද්දී අර pins එක move වෙනවා පේනවා right ලස්සනට මේක ඇතුලෙන් පේනවද මේ pins එක move වෙනවා පේනවා if these pins are collinear right which means if one pin is completely covered by the other pin which means they are in a straight line they are collinear right which means you are in the exact correct direction of the emergent light ray එකේ direction එකේම තිබ්බොත් නේ අර ray එකට cover වෙන්න ඕනේ දැන් මේ direction එකේම නම් ඔයාගේ eye එක තියෙන්නේ නේ හරියටම මෙතන තියෙන pin එකට මේ pin එකේ image එක cover වෙන්න ඕනේ අන්න ඒක එහෙනම් මට මෙතනින් පේන්න ඕනේ right so likewise you have to identify the instance when P1 and P2 are collinear right අන්නේම collinear වෙන instance එක මේකෙන් identify කරගන්න ඕනේ. ඒ කියන්නේ මේක මේ එකපාර නිකන් මෙහෙම බලපු ගමන් pin එක ගන්න බෑ. You have to move your eye here and there and then you will see how P1 and P2 moves. මේ P1 P2 එකේ images මෙහෙම move වෙනවා. දැන් ඔයගොල්ලන්ගේ පැත්තට පේන විදිහට පිවුවොත් මෙහෙම මේ දෙක move වෙනවා. ඒතර එක point එකක් එනවා මේ විදිහට එකකින් cover වෙනවා. At that point you are taking the third optical pin out and as the third optical pin is collinear with these two you have to place that right ඒ කියන්නේ මේ මෙතන මම pin එක ගැහුවා නම් ඒක හරියට ගැහුවොත් මේ දෙකේම images දෙක මට වැහෙනවා. අයි දැන් මම මේ පැත්තෙන් eye එක තියාගෙන ඉන්නේ. Now we are keeping the eye somewhere here. Right? We are keeping the eye somewhere here. ඒතකොට දැන් මේකේ images දෙක තියෙන්නේ මෙහෙම. මෙන්න මේ වගේ තැනක මේ objects එක තියෙන්නේ මේ pins එක තියෙන්නේ. ඒතකොට images දෙක මට දැන් මෙතනින් පේනුණා. මම මේ පැත්තේ දැන් තව pin එක fix කරන්න හදන්නේ. එහෙනම් මේ pin එක හරියට fix කරා නම් මේ images දෙකම වැහෙනවා. Right? As both P1 and P2 are collinear with P3 we are going to fix P3 right එතකොට P3 කියන pin එක mark කරගන්නවා මේ fix කරගන්නවා මේ වගේ තැනකින් අපි මේක fix කරනවා නෝම පෙනිච්ච තැනින් fix කරනවා right එකක් හරි then again observing through the surface we have another pin we have to place P4 fix P4 as all three are collinear right එතකොට P4 එක fix කරද්දි by the time you are fixing P4 all three are covered. All three are covered to each other. Right? මේ ළඟම තියෙන pin එක විතර අපිට පේන්නේ. Got it? එකම straight line එකනේ මේ ටික තියෙන්නේ. එකම straight line එක in terms of the optical ray. මේ optical ray එකනේ refract කරලා මේ පැත්තට එන්නේ. Then they are on the same straight line. Then by the time you are fixing P4, right? All four should be collinear. Right? All four should be collinear. Right? මම පොඩ්ඩක් මෙහෙන් අදින්නද? All four should be collinear. This is P3 and this is P4. Right? Then මේ දෙක fix කරලා ඉවරයිනේ. මේ දෙක fix කරලා ඉවරයිනේ. මෙන්න මේ points එක mark කරගන්නවා. After marking the points, we are taking the prism off and have to do some construction. मैंने में construction ने करना मेरे बार. Now we have 4 points with this line, right? Prism එක අයින් කරා, sheet එක කොහොමද තියනවා? Prism එක අයින් කරලා sheet එක කොහොමද තියාගෙන මේ construction එක කරනවා. මම උතන පේන්න නැති නිසා මේක අදින්න. Right? මේක තියනවා දැන්. Prism is removed. මේ it is taken out from the sheet. මෙන්න මෙහෙම තමයි prism එක තිබ්බේ. Right? ඒතර P1 P2 ගේ direction එක මෙතන තියනවා. P1 and P2 like this. Right? ඊට පස්සේ මේ පැත්තෙන් තියනවා P3 P4 ගේ directions. P3 and P4 like this. Connect these two. Right? මේ දෙක connect කරනවා. මේ දෙක connect කරා නම් this is the emergent ray. එහෙනම් මේකයි connect කරා නම් this is the refracted ray. Like this. මෙන්න එහෙම ray diagram එක complete කරනවා. Right? Now angle of deviation is the angle between the original direction of light ray and the final direction of light ray. Right? මේ angle එක මම පොඩ්ඩක් වැඩි කරලා අඳිනවා. නැත්තම් deep වෙන්නේ නැහැ. Now right, P3 and P4 මෙහෙම මේ දෙකක් තියෙනවා. Emergent ray එක තියෙනවා, එහෙනම් refracted ray එක තියෙනවා, මේකක් තියෙනවා. Right, then if you extend this is the original direction of light ray and this is the final direction of light ray. Angle between these two is angle of deviation. Then angle of deviation at 30 or the incident angle 30 can be measured. Right? We have to repeat the experiment for all these angles here. Right? Repeat the experiment for all the angles. Then we have these data on a table now. අපි මේක table එකක් ගමු. There are points no. මොනවද තියෙන්නේ අපි ගාව? I තියෙනවා. I1 නෙමෙයි. We have I values ටික තියෙනවා. And we have D values for the respective I values. Right? එහෙනම් මගේ I values එක නෙමෙයි තියෙන්නේ. 30 35 40 45 50 55 likewise. Right? There's a respective D values එකක් මෙතනට දැන් එනවා. Now we have pairs of I and D. We are going to plot the variation between deviation and angle of incidence. Right? Using these points, we are going to plot the variation. After plotting the variation, we will be seeing where the angle of minimum deviation is, and we are going to quantify the value. We are going to calculate the value, determine the value. Right? දැන් මෙතනින් හරියටම angle of minimum deviation ඔයාලට හම්බ වෙන්නේ නැහැ. අපි දන්නේ නැහැ නේ ඒක තියෙන්නේ I වල මොන value එකේද කියලා. ඒක 40ද නැත්නම් ඒක 38.9ද මොකක්ද කියලා අපි දන්නේ නැහැ. හැබැයි graph එක ගන්න පස්සේ from the graph we can see the minimum point. අන්න එතනින් ඒ value එක හොයාගන්නවා. Because මේ values ටික හරියනේ. එහෙනම් ඉතින් graph එක ගන්න පුළුවන් නේ. Right? ඕක තමයි කරන්නේ. So මේ තියෙන්නේ for the first one. Now we are repeating the same for all the angles here. Right? හතක්වත් ගන්න පුළුවන් නම් හොඳයි. Right? Minimum 7 වගේ ගන්න පුළුවන් නම් හොඳයි. 6 වලින් ටිකක් අද ඒ කියන්නේ අපි usually 6 නේ ගන්නෙ for linear graphs. මේක linear graph යන්නේ මේනේ. ඒ නිසා curve එකක් තියෙන හින්දා points වැඩි තරමට ඔයාලට ලස්සනට curve එක එනවා. නැත්නම් අර curve කරගන්න දැන් පේන්නේ නැහැ. straight line එකක් නම් කොහොම හරි ඒක straight කියන්නේ directional නෝ. ඒ කියන්නේ direction එක දන්නවනේ. හැබැයි curve එක හරියටම curve වෙන විදිය පේන්නේ නැහනේ. curve එක. ඒ නිසා points වැඩි තරමට හොඳයි. Minimum we need 6. Right? 6 තමයි minimum. හැබැයි ඊට වඩා වැඩි වෙන තරමට හොඳයි. Right? මේක සාමාන්‍යයෙන් 30 වගේ ඉඳන් පටන් ගන්න 70 වගේ වෙනකන් ගන්න පුළුවන් නම් you will get a more accurate graph. Right? 5 by 5 70 වගේ වෙනකන් ගන්න පුළුවන් නම් data points එතකොට 12 වගේ එනවා. මේක කරගත්තා නම් ලස්සන graph එකක් එනවා. Right? Basically මේක තමයි අපි experiment එක ඇතුලේ කරන්නේ. පොඩි වැඩක් මේ concept එක තමයි ඔයාලට දාගන්න ඕනේ. Right? white sheet එකක් ගත්තා, මේ ටික ඇඳගත්තා. දැන් මෙතන different angles of incidence තියෙනවා. ඒතර equilateral prism එක තියෙනවා. prism එක තිබ්බා. මෙන්න මේ pins එක ගහගන්න එක තමයි මේකේ critical part එක. මේ pins දෙක වැරදුනොත් ඔක්කොම ටික වරදිනවා. Right? Placing these two pins as they are collinear with P1 and P2 is the critical task here. ඒක පොඩ්ඩක් carefully කරගන්න ඕනේ. carefully and mindfully. Right? මේ prism එකේ මෙහෙට මෙහෙට හොල්ලා ගන්න නැතුව ලස්සනට තියාගෙන කරගන්න ඕනේ. Right? ඊට පස්සේ මේක අයින් කරලා මේ වැඩේ කරන්න ඕනේ. ඊට පස්සේ first එක ඉවරයි. Then move the prism, keep the prism on this one again. 35 එකට තියනවා. තියලා මේක ආයි කරනවා. ආයි පොඩියකට තියෙනවා. ආයි මේක කරනවා. කොහොම කර කර මේ ඔක්කොම ටිකේ angle of deviation හොයාගන්න තියෙනවා. right? වැඩ තේරෙනවද? right. Then write down as method. Write down first point. මේක ඇඳ ගන්න එපා දැම්ම. Write down first point. Draw a straight line. Draw a straight line. Draw a straight line. Draw a straight line in the middle of white sheet. Draw a straight line in the middle of white sheet. Draw a straight line in the middle of white sheet. Draw a straight line in the middle of white sheet. And construct few normal lines. Construct few normal lines to the straight line and construct few normal lines to the straight line. Second point, mark angles starting from 30 degrees. Mark angles starting from 30 degrees to each normal drawn. Right. Take this down now. This diagram. First one, only the first one. මේක විතරයි. Finished. Next point. Next point. Mark incident ray. Mark incident ray. Mark incident ray. Mark incident ray. Mark incident ray using optical pins P1 and P2. Mark incident ray using optical pins P1 and P2. And observe, and observe, and observe its image through, and observe its image through phase AC, and observe its image through phase AC, and observe its image through phase AC. Next point. Fix optical pins P3 and P4. Fix optical pins. Fix optical pins P3 and P4 as they are collinear. As they are collinear. As they are collinear with the images of, as they are collinear with the images of P1 and P2, as they are collinear with the images of P1 and P2 seen through AC. Seen through AC. Next point. Next point. Remove prism. Remove prism. Remove prism. After marking its boundary. Remove prism after marking its boundary. Remove prism after marking its boundary. Next point. Extend light rays properly. Extend light rays properly. Extend light rays properly. Extend light rays properly. And obtain the correct path of light ray, and obtain the correct path of light ray. Next point. Measure angle of deviation using the ray diagram. 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 Right? Okay, now take this down. This one, only this one, not the table, this one. P1, P1, P2. P1, P2, this one is P1. P1, P2, P3, P4. And clearly show angle of deviation. And clearly show angle of deviation. Right? Oh, pakai karan tiba nih. radiation. Okay, right. Next point. Repeat the same experiment. Repeat the same for all other angles. Repeat the same. Repeat the same for all other angles. And record angle of incidence against angle of deviation. And record angle of incidence against angle of deviation in the following table. And record the angle of incidence against angle of deviation in the following table. Take down the table. Right. Next point. Next point. Plot the variation between I and D according to a suitable scale. According to a suitable scale. Right. Take this down. Now we will be marking the points we got here and going to plot the curve. And when we plot this curve, listen. When we plot this curve, it's recommended to use a graphing ruler. Graphing ruler කියන එක දන්නවද? අර සමහර අර පොඩි උන්ට තේරෙන්නේ නැති කාලේ තරම් දෙන්නේ අර නවන්න පුළුවන් රූලර් එක. අර උන් නවලයක් කඩාගන්න. අර දිග එක. ඒක තමයි graphing ruler කියන්නේ. Graphing rulers means a flexible ruler or දැකලා ඇති. A flexible ruler which is usually much lengthier than 30 centimeters. 50 centimeters වගේ තියෙනවා. Around 50. දැකලා තියෙනවනේ. Graphing ruler කියලා එකක් තියෙනවා. මෙහෙම හොඳට නවන්න පුළුවන්. Right? Using that graphing ruler, only we can get the exact correct shape of this. නිකන් අදින් අදින්න අමාරුයි. අදින්න පුළුවන්, but not the exact one. Right? So it is recommended to use a graphing ruler. Graphing ruler එකක් use කරලා, then now we have marked these points here. No. We have marked these points here. No. Then by connecting the points, you have to complete the graph. Right? මෙන්න මෙහෙම දැන් points එකක් තියෙනවා. Minimum point එකට point එකක් එහෙම එන්නේ නැහැ හොඳේ. So likewise, you will get these points with a spread, something like this, right? These are the readings we took, right? For 30, 35, something like this. This is like for 30, 35, 40, 45, 50, 55, 60, something like that, right? And variation of deviation is, angle of deviation is always it's reaching a minimum value, and again it will be increasing. අපි මේ ටික කරද්දී අපිට පේනවා ඒක හොඳ because definitely we will be exceeding the minimum deviation. You will be doing it beyond minimum deviation, right? එතකොට අපි මේ readings කරනකොටම අපිට ඒක ටක් ගාලා notice වෙනවා, right? Angle of deviation decreases and then it increases. because it is reaching a minimum. Then after plotting this graph, right, you have to, this is according to a scale now, you have to take the respective reading here, right? This is called d min, angle of minimum deviation, right? And this is the respective angle of incidence for angle of deviation, right? So in that case, in the theory we have discussed, for all other angles, listen, for all other angles, there are two possible ways of having the same deviation because of the ordinary property of light, right? Then when this angle becomes 30, right? If this deviation is say 38, then if the light ray, if an opposite light ray comes from this side, then again the same deviation occurs, right? Ordinary property of light. But for the minimum deviation, there's only one possible angle of incidence. That is why we say I1 equals I2, right? Okay. Okay, this is the graph we get, and our target is determining d min. D min can be determined, angle of minimum deviation can be determined using the graph itself, right? Okay, graph එක දෙන්න කියලා මම point එකක් දුන්නානේ. Right, take down the graph. Take down the graph. Take down the graph. Take down the graph. Can you repeat the last point again? I don't know which last point you meant, right? But you are not on a Zoom meeting, you are on a YouTube live. Just rewind and see. Okay, finished? Write down below. Write down below. Determine angle of minimum deviation. Determine angle of minimum deviation. Determine angle of minimum deviation using the graph. Determine angle of minimum deviation using the graph. Determine angle of minimum deviation using the graph. Next point. Next point. Refractive index of prism can also be determined. Refractive index of prism can also be determined. Refractive index of prism can also be determined. Can also be determined as discussed in the theory. As discussed in the theory. Theory කියන්නේ මේක theory එකේ mention කරපු එක. As discussed in the theory. Right? Equation එක තව පාරක් mention කරමු. As discussed in the theory. Right? Same equation, n equals sin a plus d min over 2 over sin a over 2. Right? So we took an equilateral prism. A is known 60, right? D min is known from here. Since A and D min are known, n can be determined. Right? Mention this again. Write down below. Since A and D min, since A and D min, since A and D min, since A and D min are known, simple n can be determined. Since A and D min are known, simple n can be determined. Since A and D min are known, simple n can be determined. Right. Okay, that's it. quickly go through what is given here. And in clear representation, drawing board, drawing pins, a white sheet of paper. Right? The white you have to write it as white because that's the most clearly visible color. Right? White. When we have drawn something on a white sheet, that's more clear, no? Right? That's why. Then for optical pins, a ruler, protractor, right? Theory, when the angle of incidence is I is gradually increased from a small value to angle of deviation, first decreases, reaches a minimum. This is the variation, now we know. Then increases, the angle of deviation corresponding to minimum state is the angle of minimum deviation. That is called d min, not just d, that is d min. D min, or sometimes it is labeled as dm. D min, or dm, right? Fix the white sheet of paper on the drawing board by drawing pins. Draw the straight line AV close to the middle of the paper. Right, mark 7 points. Right, make it 7 minimum 6 we need. Right, 7 ut madi hode, make 7 ut madi. Right, then meter 7 higher the number of points you have, more accurate d min, more accurate curve you get, then more accurate d min you can determine. Right, make curve last Sunday another right, more smoother the curve you have here. Right, more smoother the curve you have here, more accurate your d min is. Right, make sure the lines inclined at angles. Right, right. Right. Then the other things, right? Method remarks. Remarks means these are the special points to be like considered when you are doing the experiment. Remarks. Remarks. Listen. First one is this. Now, when we are fixing pins, when you are fixing pins, you have to fix pins as they are like far as possible, because this is what happens when you connect the pins. Otherwise, say you have one pin here, you have one pin here, right? Mega P1 kilogram, you have one pin here, and you have the second pin here, right? P2 kilogram, second pin there, and you have another state here. Mistakenly, you have marked these are two possible points. You can mark P2, you can keep P2, right? Make a mark. See, this is the deviation that you are going to make, right? But if these pins are more apart from each other, right? If these pins are more apart from each other, right? P2, but still the variation is less than this, no? Right? Deviation and the variation is less than this, right? Which means more apart the pins are, more directional our ray diagrams, directions of rays, right? That's the thing. So, pins you have to keep some space, some possible space, as you have the spread in your drawing sheet, right? After drawing sheet, you have drawing sheet. A4 that is much bigger than that. Utilize the space in the drawing sheet by fixing the pins as far as possible, right? And make a thought meet order during and make a thought straight pen. Make a Durutagan. See, now the deviation is even less. Deviation is even less. Small angles. Right? Pointer there on. It is clear, right? More apart the pins, more directional the light rays. Right? Write down first point under remarks. First point. Fix optical pins. Fix optical pins apart from each other. Fix optical pins apart from each other. Fix optical pins apart from each other as much as possible. Apart from each other as much as possible. Apart from each other as much as possible. Within brackets, the deviation of light ray, the deviation of light ray. When connecting two close points, when connecting two close points, is higher than the deviation when connecting two far points, is higher than the deviation when connecting two far points, is higher than the deviation when connecting two far points. Mention these examples, these three ray diagrams. Right? Next point. Observe the bottom of optical pin. Observe the bottom of optical pin. When fixing P3 and P4 using images of P3 and P4 using images of P1 and P2. Within brackets, write down errors caused due to inclination of optical pins slash not being vertical can be minimized. Not being vertical, close the bracket, can be minimized. Right. Which means now when we fix optical pins on the drawing board, it is not going to be exactly vertical always. No? Right? You are fixing the pin on the board. Right? It is not always exactly vertical. Right? Then if these two has a small inclination, you won't see that collinear equation, even though you are moving the eye here and there. But if you focus on the bottom is exactly on the line. Bottom is on the line. If you focus on the bottom, then if the bottom point is covered, which means we are on the line, collinear. Right? So incline because when you are focusing on the bottom is on the line, bottom will be covered. Right? If a pin is not inclined, what happens is the fixed point is same. It will be inclined from here. Right? Even though it is inclined, if you focus on this point, you won't make any error. Right? That's the point here. Right? Next one is, look at the board first. Using a comparatively larger prism is better, because even if you have a small deviation when you are trying to keep this on the line like this, it will be clearly visible. More larger the prism, more clear the deviation. Right? Because you have to keep this exactly on the line you have drawn here. Right? Otherwise all these angles are going to be different. Right? When you try to keep this on the sheet in line with the horizontal line, right? If it has a deviation in a larger one, it is more clearly visible. Then you can easily correct it, right? Then using a comparatively larger prism is better to minimize errors, right? Next point. Using a comparatively larger prism with wide faces is better to easily coincide is better to easily coincide the prism with the straight line, to easily coincide prism with the straight line, to easily coincide the prism with the straight line, to easily coincide the prism with the straight line. Right, take this down. Prisms. అయితే అయితే ఒకటి అందులో దేనిదే అవునండి. Right, finished. Any questions on experiment 2? Man 2 కి దాలत any questions on experiment 2? Any questions on experiment 2? All good? All good? Online? Any questions? The next one is also from a prism, from prisms, right? Prisms experiments they got thin and we have 2 experiments using prisms, 2 from spectrometer, 2 from lenses, right? And 1 from the glass cube. That's how the 7 is coming, right? Okay, clear, right? Then let's move on. Experiment 3. By the way, did you see the splashing of